Killen, and if Donald Trump lasts 4 years as President of the United States, and if he does not ease up on the use of fossil fuel in this nation, he will contribute to adding 80 billion tons of carbon dioxide into the atmosphere and another 80,000 into the oceans. I believe Trump is helping to create a multi-billion-dollar opportunity to help remove that carbon dioxide from the atmosphere. On this show, I have invited Arthur Burtis. He has developed a solution to help remove the carbon from the atmosphere. Before I start interviewing him, I want to share an announcement. On June 23rd, Stanford University will be producing its annual Silicon Valley Energy Summit. That's June 23rd. And VIPs from all over the nation will come to this event. And it's truly a very informative event. I have accepted an invitation to put in the lobby of the Arriaga Alumni Convention Center another one of my very large, relevant paintings. And I've also been invited to put a 15-foot painting in the building when the Honorable George Shultz shares his recommendations for the President and Congress. My 15-foot painting will interpret George Shultz's recommendations to the President and Congress. And with that, I want to start with Arthur.
Michael, it's a pleasure.
How are you today?
I'm fine, and yourself?
You're the first guest that has been on this show that has less hair than me.
Well, you know, it comes with the package.
Arthur, you and I met a couple of years ago.
Yep.
And I've watched you and I've listened to you, and I've been quite impressed with two things. That you are watching very carefully the developments of the increasing amount of carbon dioxide in the air, the atmosphere, and you're not only looking at it, I believe, from a business opportunity, but I've also noticed you are extremely concerned with the future of civilization.
Yes.
And you have developed a solution to help remove carbon dioxide from the air. And it seems to me it's based on, it's an air capture solution. And maybe you would like to put it quickly into perspective, and then I'd like to ask you a series of questions.
Okay. What I developed was the Solar-Air Tower-Chimney, and what I do is I move massive amounts of air, massive volumes of air.
Look at me.
And the air that I move and the way that my system is designed enables other organizations, carbon dioxide separator systems, to function within and on the perimeter of my solar capture system, because everything works with solar energy.
What is your solar capture system? Let us know. Tell us.
Well, the solar capture system is a platform. And actually, this right here is just a prototype of the platform. This prototype is electrically powered only because I did prototype tests with it.
Just a second. Can I visualize it? It is a tower?
The tower is on top of the platform. The platform is almost flat on the ground. It just barely comes up toward the center to a venturi.
Okay. So, but I think we need to know that you have this physical thing, a tower, and you have some things underneath which you will explain that has the effect of pulling air into it.
Yes.
And then your technology and other people's. Okay. Now we see the tower. Please go.
Okay. My Solar-Air Tower-Chimney it's scalable, so it can be sized to be acceptable in different geographic areas. It usually works the best, and it is most efficient when it's in a climate that is basically a desert area. What I can do is, with my system, is I can take other people's solar collectors, put it around the outside, and as the air comes through their solar collectors, the carbon dioxide gets removed from the air. So the air that comes out the top of my chimney is muchly reduced, if not completely reduced, from the contents of carbon dioxide.
What's the function of these collectors?
The function of the collectors is to separate the carbon dioxide out of the atmosphere.
Maybe I have a different definition for collector. I thought these are like mirrors or something that, or solar panels that the sun hits it,
No, these are fabrics.
Fabrics. Really? Is your tower made of fabrics or just
Some
the
of my
bottom?
tower is made of fabric, but the solar collectors are owned by other organizations. I don't own the solar collectors. I own the tower that moves the air for the solar collectors.
So the sun comes down, radiates, hits those collectors, and what happens?
The sun comes down and it radiates onto my solar collector, okay? Then the carbon dioxide collectors, which are on the perimeter of my solar collector, as the air comes through those, they're owned by other organizations, the carbon dioxide gets removed from the air. So after it gets the other side of the carbon dioxide collector, it is now cleaned of its carbon dioxide.
So within the tower, there are these gotchas, chemicals that grab the carbon dioxide and...
Within the collector, the carbon dioxide collectors that are owned by other organizations, there are sorbents. They're called sorbents, and they actually absorb the carbon dioxide out of the air as it passes through them.
Okay, good. Good. So what gets the air to really flow effectively, forcefully
Pressure
through?
pressure drops because of the height of the chimney, and also the fact that in the solar collector, now not the carbon dioxide collector, but the solar collector of my chimney, as the air comes through from the outside edge, as the air comes through, it gets warmer and warmer and warmer and warmer because there's more and more solar energy being put into it. And eventually it hits the venturi, which is at the bottom of my chimney.
So this is at the bottom of your chimney.
Yes.
And the air is coming in here?
Yes.
Or way down here?
No, in here, which was represented by this. This represents ground level right here.
Ground level.
Okay, that's ground level. And then my solar collector, which is clear. It's a clear solar collector. It's not clear on my prototype because I needed to use electric energy to make a semblance of the same heating of the air that the solar collector will do.
So you built a prototype?
Yes.
And these are photos?
Photos of it, yes.
Of it. And I'm still having a problem understanding something when you said a third party provides
The carbon dioxide collectors.
and those are inside, no, outside.
Those are on the perimeter. Those would be basically a sheet that went around the perimeter.
Oh, the perimeter.
The perimeter. This is my solar collector here.
Yeah.
Okay, and so the carbon dioxide collectors would be all around the outside.
So let me see. So does air come in, and as the air comes in with the carbon dioxide, it goes by the peripheral.
The periphery, which is the carbon dioxide collectors. So once the air gets past the carbon dioxide collectors that are owned by others, and it gets inside my solar collector and continues to heat up and move faster and faster and get hotter and hotter, it has already lost its carbon dioxide at the very perimeter.
Okay, interesting. Who are some of the companies that make the collectors, the grabbers?
One of the companies is called Global Thermostat.
Okay, so that's what they make. They don't make the whole system, or
they just make the collectors.
Just the collectors.
They make the carbon dioxide collectors. Now, the word collector works in both but is used for both the carbon dioxide collector, using the word collector, and the solar collector, using the word collector. But the solar collector and the carbon dioxide collectors are not the same animal.
What is the function of the solar collector?
To heat up the air and make it move faster and faster and get hotter and hotter. The more you heat the air, the more it expands. The more it expands, the lighter it is, the faster it can move. As it goes through the venturi, it goes into our bladed turbine to make electricity.
Are the turbines yours?
No, the turbines are from other parties again,
Okay.
and the turbines could be from General Electric or whatever company
Okay.
that makes the turbine.
So let me see if I got this right. The air comes in underneath with carbon dioxide in it. As it goes up, you have these collectors that one of your partners has them, and it grabs the carbon dioxide.
Separates it from the
solar
atmosphere.
panel, the solar creates heat,
Yes.
which helps make the air flow up quickly, and out it goes, and you
Yes.
have turbines at the top that spin and create electricity.
Well, yes. The turbines are more in the venturi at
Okay.
the bottom of the actual chimney, and the chimney is not a straight parallel chimney. The chimney is a diverging chimney.
Okay, so I saw something in your literature that looked like, or I heard, your chimney is inflatable.
There are toroidal, which is an inflatable rubber chimneys that could be manufactured. This was actually brought to me by a professor in a Canadian university that I worked with a few years ago, where we could build these so that they were inflatable and they could be brought to different heights by the amount of air pressure that was put into the rubber inflatable chimney. Yes, they can be inflatable.
So I would assume right now, since you have put this together, an understanding of thermodynamics and a few other things, and the understanding of the building design of chimneys, you team up or are looking to team up with different partners, investors, to help your partners seize this both multi-billion-dollar market opportunity I met, and I think also, from what I've observed of you, you have a great interest in humanity.
Yes.
And you like nothing better than to get rid of help get rid of some of that carbon dioxide that's up there that is going to and is already making our climate different than it used to be.
Yes.
Is that right?
Yes.
So just want to jump for a second. Anyone building these kind of solutions to separate carbon dioxide from air?
No.
No.
Not to my knowledge. At this time, the separators for carbon dioxide, for collecting it, are using fossil fuel to power fans to blow the carbon dioxide through their separation fabric, their carbon separated fabric. Except for one person who says that he does not need to have any type of air movement through it, or it's not that, he does need air movement, but it would be ambient air, natural air movement with winds and breezes. It wouldn't need to have the air purposefully move through.
With your design here, are you getting enough energy to pull the air in, separate the carbon from the air, and spin the generators? Or do you have to get energy from, let's say, a solar plant?
No. There's enough energy from our solar collector. There's enough energy from our solar collector to be able to pull the air in from the outside edge of the solar collector through the carbon dioxide collectors, others apparatus, and still be able to turn the turbine, the electric turbine in the venturi, others apparatus, to create electricity.
Okay. What about when these generators spin, creating electricity? Can you make any other kind of product, a different kind of fuel out of it?
Well, the generators are going to create electricity. They're not going to create another type of fuel beside electricity. But when the air heats up in the collector, to be able to make the speed and the temperature of the air faster through the venturi to be able to create more electricity with the turbines, we can pull the condensation out of the air and we can create potable water.
Okay, so it makes me think of Africa and other desert places where
Perfect.
they do need energy and also they need water. But what about, you're making electricity. Are you envisioning that electricity going into the grid, or are you thinking about sending it to manufacturers who might be making ethanol or cement that need
I'm envisioning that the electricity would be put into the grid for any extra electricity that was left coming out of the turbine that's in my system. Now, the electricity would also be used on certain close proximity situations and operations that would happen to be able to make the carbon neutral liquid hydrocarbon fuels that can come out of carbon dioxide.
Like what? What's a liquid fuel?
Diesel, gasoline,
Diesel?
and jet fuel.
Jets. So airplanes need a liquid fuel.
Yes.
Okay.
The engines that I know on airplanes, the jets
Yeah.
that I know, they use a liquid fuel.
Yeah, and I think there's growing pressure for new generations of planes that are more energy efficient.
Yes.
And that's going to take us somewhere. But are you envisioning partnering with companies that will take what you're producing here, the carbon, and the electricity, and turning it into liquid fuel?
Yes.
You do have that thought.
Yes, yes, definitely. And if I could just expand on that just a little bit, we are willing, we're more than willing to, I mean, and when I say we, I mean myself and my different people that I know that have the other operations, the other apparatus, to talk with any type of a company that wanted to possibly get together with us. Now, let's just put the abstract out there and say that we were talking to one of the huge oil companies. The huge oil company, if they were to take and make it so that they had this type of apparatus along with the other apparatus that separates the CO2 out of the atmosphere and also turns it, another system turns it into the diesel and jet and gasoline fuel, the large oil company would all of a sudden have another access point for a new source of fuel. So this fuel that would come out of this, out of the result of this, would be carbon neutral. In other words, it would be taking the carbon out of the atmosphere, turning it back into liquid hydrocarbon fuel, and then it would be going back into the atmosphere by being burned in cars, trucks, and planes.
Okay, that's
full
interesting.
cycle.
Now, I started the show by saying that a huge, maybe it's $1 trillion market, who knows, depending upon how things go. But do you actually believe that if we continue to go the way we're going, we will be putting so much more carbon dioxide up in the air, in the atmosphere, that solutions like this are really needed?
Absolutely necessary. It's absolutely necessary to somehow thwart the increase in carbon dioxide in our air. Otherwise, in the eventuality, when it gets warm enough on this planet, it will alter the paths of the trade winds and the oceanic currents, which means that we will no longer have a regular seasonal system of 4 seasons.
Okay, I've had guests on here who have written books on the tipping point of the Earth. And I have had Nobel Prize winners in physics like Bert Richter, who used to run one of the Department of Energy laboratories. And I've had Sweeney, Jim Sweeney, head of the Precourt Energy Center, Paul Ehrlich. They all echo what you are saying. We are heading to a situation where solutions like this, we may become desperate for them down not too far away. And I know this is political and controversial, but before I came here for the Tonight Show, but I haven't used the information, the author of A Cubic Mile of Oil did all the calculations, tremendous amount of calculations on how much more carbon dioxide we will put up in the atmosphere over the next 4 years if Trump is in there. And but now I'd like to ask you, who's going to invest? What type of company is going to invest in your solution, or what kind of company is going to buy it, or organization is going to buy it? Government agencies?
Well, that would be nice if the government would put the money into it, because the government definitely has ways to create money. But at the same time, Google, the different organizations such as Tesla, okay, and they have the capital available to be able to bring this and my other associates, apparatuses, if I could use a plural on that, to the point of putting them together on a major-sized prototype so that we can absolutely prove beyond a doubt that we can take the carbon dioxide out of the atmosphere and turn it into a carbon-neutral liquid hydrocarbon fuel for cars, trucks, and planes, and boats.
So you see people, organizations like Google who think big. Maybe a Facebook thinks big. And Tesla, and that would be very good. And where are you located, by the way?
Marin County, California.
Marin County. Well, where?
West Marin. West
Marin.
County, yes.
But the rest of the world does not know where Marin County is.
Well,
west.
Marin County is approximately 40 miles from central San Francisco, north.
Oh, so you're near San Francisco.
Yes.
40 minutes, a half hour?
40 minutes.
And did I hear you're in a valley called the San Geronimo?
San Geronimo.
San
Geronimo Valley, yes.
You know, I go there sometimes. Okay, so what is the next step with your project?
The very next step is to find the funding to be able to make the prototype to prove the point that we can literally create fungible, which means similar, drop-in, which means you can put it in any tank, whether it's a tank that's at a gas station or a tank that's in your car, gasoline and diesel and jet fuel.
Okay. So now you've been working on this for quite a while.
Yes.
And I can tell you're not excited when I talk about multi-billion-dollar opportunities. You're more excited about getting the world to use your technology to do some good. And you own rights to some of these things?
All of the circumstances as far as the inventive processes that are internal and external on this are still held in trade secret abeyance. Yes, I own it.
Okay. Now, I know where I came from to be able to make something like this painting. I know where I came from. Where did you come from to be able to put a design like this together?
I've always been mechanically inclined. I started into the trade of masonry construction many decades ago. I say many, I said it 4 times because it's 4 decades I've been a masonry, tile, and concrete contractor. I should say for 4 decades I've been doing that trade. I've been a contractor for a couple of decades. And one of the things that I did was I built a lot of chimneys and a lot of fireplaces and a lot of outdoor areas with chimneys. Some of the chimneys were 2-3 stories tall.
Wow.
And I learned, building those, I learned what happens to air when it gets heated, how you can direct it, how you can make it go faster. Then I realized that, okay, we can do that. We can do this in a much bigger scale than just these, 3-story tall chimneys. We can do this in 300-foot tall chimneys. We can take and put huge solar collectors on the outside, so instead of a fire in a fireplace, we're using the sun to heat our air. Then we can take and we can move this through and make the turbines move, spin, so that they literally create the electricity. And then I ran into the people, many people, and I've been to visit them in many different locations, universities and Stanford Research Institute and things like that, that have the that have the carbon dioxide collector that would be on the outside of this. Do you mind if I move this and put another one up that shows a little bit more?
Sure.
It'll take me just a second.
Sure.
This is a similar, the same picture, in that now you're seeing the top of the chimney as it goes up that we used in the prototype.
That's the chimney.
That's
Here it
the
looks
prototype.
like a pipe.
Well,
it is sort of.
Well, a chimney is sort of a pipe.
Sure.
I mean, the air goes through it. This was not built in a divergence. We later took this down and we built a divergence into it, and we have the records here on the test that we did, which are totally prototype. Totally private. Yeah. We found that when we diverge this, we can make it move even faster. Then we found, I'm going to move this off and I'm going to bring another one. Then we found, and this is an abstract of it.
Yeah, what?
Then we found that we can build inner towers, inner chimneys, and our inner chimneys increase the speed and the volume of the air. So there's many things that we found with engineers, and particularly I want to mention a man's name. His name is Bob Hunke, and he worked with me as an engineer on this for years. And I have great respect for him, and he'll be in on this when we get going.
Good.
So that right there is an abstract. This is the collector out here.
Yes.
You have, this is the ground right here. That's the ground. This is the product input area where the air is coming through. This is the lower heated plate, the lower cover. Upper heated plate, there's the chimney that goes up. So we're collecting the carbon dioxide. In the center, we have our venturi, and in the venturi, we have the turbine that's creating electricity.
Very good. And I'm starting to notice that the clock is running down, and maybe, I have a little bit of time left, but it seems to me in this world we have chemical engineers, electrical engineers, petroleum engineers, and we're all looking at the carbon dioxide issues and the needs of the energy requirements of a nation, okay? But it seems you are the only one I have met who has knowledge, experience dealing with this physical structure, chimneys. Mm-hmm. And I, needless to say, I'm not an engineer, but the flow of air and how to get it to do things is extremely important.
Very important.
Now, if people wanted to contact you, and this is about my last question, how do they do that?
They can contact me by email, or they can contact me by telephone.
Okay. How about the name of your company again?
Solar Air Tech, LLC,
okay,
is the name of the company, and the Solar Air Tower-Chimney is the name of the product.
Okay, and did you trademark some of these things?
I did through different ways of paper movement around in different locations, selling different parts.
Okay. So, you've been a good guest. I hope I have helped you share your message with decision makers out there, and I hope some of them get interested or more interested in it. I actually know there's interest because before I came here I contacted SRI and I chatted with them and they told me about a demonstration, and it's a real need to help remove carbon dioxide. A lot of people are working to make sure very little goes up in the future. But anyway, Arthur, thank you very much.
You're very welcome.
Hi, I'm Michael Killen, the Killen Report.